Good evening, everyone. A warm welcome to each one of you on today's webinar on Medallion Architecture. I'm Harjun, your host for the session, and I'm thrilled to have you all here. On behalf of Kalpita Technologies, we are excited to share our valuable insights with an enthusiastic audience. About Kalpita Technologies, before diving into the topic, let me introduce you to Kalpita Technologies, the organization bringing the sessions to you. We are a leading enterprise software development company with 6 years of innovation and excellence, headquartered in Bangalore, India, and with a growing presence in Austin, Texas. We are built a reputation for delivering cutting-edge solutions. We are proud to be a Microsoft Gold Partner and SOC 2 certified and are recognized as a great place to work from 2021. We strive to combine the technology and talent to drive transformation for our clients globally. About today's speaker, now let me introduce the person we are all here to listen to, Vinuthan, our Director of Technology at Kalpita Technologies. With over 20 years of expertise in data engineering using the Microsoft stack, he is a seasoned leader in technologies like SSIS, SSAC, SQL Server, ADF, Fabric, Databricks, Python, and Power BI. His knowledge and insights promise to make this a session you won't forget. Without further ado, I hand over the session to Vinithan. Vinithan, the floor is yours.
Thank you, Arjun. Thanks for the introduction. Can you hear my voice?
Yes, Vinithan, you're all clear.
Hello, good afternoon, everyone. Uh, Today I'll be talking about the medallion architecture. Yeah. So my name, yeah. So as Arjun introduced me, like I have around 20 years of experience in SSIS and all the data engineering tools, primarily SSIS, Python, Databricks, Fabric, and all the tools that are available in Microsoft Stack on the Azure services. So today's agenda for today is to start with, we'll start with understanding the terminologies on like medallion, and then I'll walk you through or an overview of the medallion architecture, followed by the different layers that is there in the medallion architecture, and then a brief note on Microsoft Fabric, and we'll end the session with the Q&A. So there are some common terminologies that you will listen to whenever we talk about Medallion architecture. Among them, few are like a design pattern, data engineering, best practice. Then we have layered architecture. Then we will commonly listen to the bronze, silver, and the gold. And then we will frequently people talk about the Databricks, Fabric, the Delta Lake, the Lake House, and this is associated with like large data quality, and we have the scalability, the modularity, and the streamlined data process. So basically, medallion architecture is a design pattern that is commonly used in data engineering, and it is a layered architecture, uh, and with layers like bronze, silver, gold. When we follow these kind of design patterns, basically we end up following some best practices whenever we are migrating the data from one system to another. And with the best practice being followed, we achieve data quality, scalability, and modularity. Okay. As a result, there will be a streamlined data process, and it is commonly associated whenever we talk about medallion architecture. You commonly listen to Fabric, Databricks, and then Delta Lake, Lakehouse, and like processing of large data or any kind of any size of data. So, in short, it is a design pattern for migrating data or ingestion of data from one system to another. So yeah, whenever we just I was very curious in understanding, okay, what is medallion, right? Why that name? So medallion in a simple dictionary form is like a round metal disc that is worn for decoration on a chain. And we would have commonly heard different medals being given to different sports people in Olympics or any other events. That's where you have heard about gold, silver, and bronze medals being given. So medallion is also, it implies a hierarchy or ranking, meaning generally you tell, okay, gold medallions are more precision than silver or bronze, and because it's the next level. So this, in similar analogy, the data layers, medallion architectures, it follows a similar hierarchy. So bronze meaning in terms of data ingestion, you have the raw and very raw data. You are not like done any cleansing activity. Then you have the silver where it's a curated data, and then you have the gold, which is a high value, business ready kind of data. So the concept of bronze, silver, or the layering of data basically was formalized by Databricks, which is a company behind the Apache Spark and the Delta Lake, and they primarily introduced to promote the lakehouse strategy, uh, 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 and they wanted to build a really scalable, organized, and efficient way of managing data for the modern data platform. So they are the ones who brought up this concept, and that's why you often hear it. People would have heard it more during the days when they program in Databricks, when they are done their data ingestion via Databricks or Python code. So Delta Lake was introduced by Databricks in 2019, and then now it is also common adopted by Fabric, Microsoft Fabric, and in Fabric it is called the Lakehouse. So this paradigm, like basically, what Databricks did was they took up the benefits of traditional data warehouse and data lakes, and then created a common data pattern or framework for implementing this paradigm. Okay, so and it kind of aligns with the high data quality and reliable data that is required for AI and ML and analytics. And today, uh, uh, this is kind of considered as one of the best practices for structuring data flow. So that's about like how the medallion came into the architecture was kind of promoted by Databricks and then now the Fabric. So the medallion architecture basically, as I talked about, that we have three. It's a layered architecture. We have three layers: the bronze, silver, and gold. And primarily, the data moves from bronze to silver and silver to gold, and then finally consumed by the semantic model. And this semantic model is further used by the business or by the Power BI reports or any other reporting tools, and it can be used by other like AI, machine learning tools to create data models. But at this point, when we see that, okay, there are three layers: bronze, silver, gold, there is a common question that can arise in our mind, especially if people have worked in data engineering. You would have also heard about you would have also heard about some conventional data warehouse workflow where these like we used to always say that, okay, we pull the data to the raw, from the raw we pulled it to stage and then the warehouse, and then it was consumed by the data warehouse for the BI analytics. So it's kind of similar, similar in terms of the layer, but not exactly the same, in the sense that the conventional layer was more ETL. It was more created to suit the ETL needs, but whereas here both the ELT and the ETL needs are addressed, and in the conventional it was more get schema driven. Like in the stage table itself, we used to conform to the schema, load the data, and then we used to put it into the data warehouse and cleanse the data and all those things. But here, it's not schema driven at the bronze. It is like as how the data is in the raw source. We would like to keep the data in the same similar fashion. And also in the Medallion architecture, emphasis is given more on maintaining the data lineage, in the sense that if there is any issue found in the gold or silver, we should be able to go back to the bronze and kind of find out, okay, where the error has come. So right from the raw data, you should be able to see what's the data. But here, once you bring it to the stage, and then everything goes to the warehouse, and that becomes the basically you don't emphasize on maintaining the data lineage in the conventional approach. And and other data warehousing frameworks that is there other than the conventional raw stage and warehouse kind of framework, or the Medallion is like Lambda architecture or the Kappa architecture, data vault. Then the Snowflake Kimball style, which is primarily used in the OLAP, wherever SSAs are completely denormalized data flow. And then for different real-time data and all, we use like different multi-hop enterprise DB, data warehouse, layered data platform, data mesh, and all the things. They are used for different use cases. Let's talk about the bronze layer. Okay, so bronze is the first layer where the data will land into. Basically, when say for example we are migrating the data from one system to another system, or from some file to some other system, right? So the bronze layer will have the data as is, in the sense absolutely they will not do anything. Like if there is some Excel file or some data from some table which is in some other source we want to bring in, we will just dump the data with minimal effort as is to the bronze layer. And it could be any kind of structured data or semi-structured data, and we are not too much bothered about the schema, in the sense, the schema is very flexible, it can change, because in the source, right, generally they can add new columns or add new attributes, the schema can change. So the design is focused on not designing, like not creating a specific schema for the source, like and in Python and language, it can be like very easily done in terms of dumping the data into the bronze layer. And the data grows incrementally. Sometimes there are some use cases where data full load has to be done, but generally we would recommend to incrementally grow the data. There could be some small deviations, like for example in Excel you may have some columns which are duplicate names, and in that case we may want to just rename those columns. And there could be some data parity issues where some of the data types, like in Salesforce you have the record data type, and these kind of data types which is not supported, you may want to kind of change it accordingly. So but with minimal changes. So there are some exceptions like data parity, and sometimes preferably incremental load, but sometimes you may want to load the data full. And the person who does this, who builds this bronze layer, right, the data engineer will build this data, and it will be used by data scientists for exploration, and analysts or app or BI users or compliance team or data ops team. And in terms of Microsoft stack tools, in some examples from Fabric, we can use notebooks, or we can use pipelines, or in we have Dataflow Gen 2 and shortcuts, and these kind of tools we can use to dump the data to the bronze. In terms of tool, I'm like more specific on the Microsoft stack, but for different, and this framework can be, it's not like just the Microsoft framework, right? This framework can be used in other tools while we are building or migrating the data using other tools as well. But the concept remains the same, but it's just that I mentioned the tools on the Microsoft stack. And so benefits is that it enables the source structure to change and without the process to fail while loading the data to the bronze. And as I mentioned, there is a data lineage, and in Fabric they have different features that is available to help you track the data lineage. And the other thing is, as it is layered, you see a modularized approach. Like you first bring the data to the bronze, it is the data is as it is, then you bring it to silver, and then you push it to the gold, and then you consume it. So it's a layered modularized approach for data ingestion, and you get a complete trail of for doing the audit and or any historical data using the delta lake versioning that is available. So these are some of the benefits, and the pain points at this layer level, right? It would be that data quality may be poor because it is as raw as how it is there in the source. Then data inconsistency could be there, and relationships could may not have been built, and it will be, I mean, it's little bit, it may be a little bit complex to process the semi-structured data. And data volume, I mean, wherever data in migration is there, we always talk about the data volume. I mean, people need to focus on the data volume. And sometimes the late arriving data, in order to bridge some relationship between two tables, the master data may come a little bit late, but you may have the fact data coming in earlier. So this kind of handling of late arriving data. So this kind of the state of the data is in that state, meaning it could be in that state. So it is a raw, purely raw data without, and the data is as is without doing any transformation. So that is the bronze layer. So once we bring in the data to the bronze layer, then we push the data to the silver layer. This is where all the transformation happens. And at this stage, or at this layer, basically once the data is cleansed, then transformed, deduplication happens. If there is any duplicate data, you will clean that. Then it will be and you will have a very curated data. So at the silver layer, the structure, it could be we could define a proper structure, like for example, in the table, if it's a table, you'll define a proper structure, and it is a standard defined schema. As you see, when the schema changes, there will be a drift from schema drift from the bronze. In the sense, there could be some calculated columns or anything. So lot of all the transformation happens at this layer. So once the transformation happens, then the data is available. I mean, the quality of data is better than the bronze layer, and it will be more consistent in comparison to the bronze. So various validation, like column renaming can happen, fixing of errors, then the any other validations and transformation process, rejection of data, all these things happens in the silver layer. And here again, in order to handle the data volume, one can do an incremental load, and we can use the features of Lakehouse in terms of schema versions. All these are inbuilt features that are available in the Lakehouse in terms of versioning and all those things. Here, when in the silver layer, between bronze and silver, there could be some data that goes into the rejection layer. And I mean, basically, it may have to go back to the business, and then they may have to revalidate it, and then you might have to re-ingest it to bring it to a proper state. So there, and this rejected data can be held in a separate exception table, and that can be separately, a report can be generated and be provided to the business for further evaluation. Again, who builds this? And the data engineer builds this. And who uses this? This is the place generally where data scientists users for further exploration, because it is at a state where cleansing has happened and some transformation has happened, and they can use it to build different data models, and it can be used by analysts and BI users, compliance team, and data ops teams. Again, we can use the ADF pipelines, notebooks, and data flow gen 2 to populate the silver layer. The benefits are that it is more reliable for analysis, and it is a standardized data formats and structures. It's a standard structure we would have built, and data redundancy would be removed, as we would have done some deduplication and other cleansing as a result of some other cleansing effort. And this will be more curated data, which will help in doing any other analysis, data exploration, and other stuff. And the pain points when we do all this would be the failure of either if the data is too large, we might have to handle the timeouts, the resource usages, and then also other failures in terms of validations. Late arriving data can upset your normal workflow. We might have to handle it in a different way, and all the typical data related validations we generally do. And there could be a lot of complex transformation, because we are really doing some kind of cleansing, right? So we could have some complex transformation as well. So once we have prepped the data, cleansed the data, once we have the curated data in the silver, then we move the data to the gold layer. So this will be the like the aggregated. It's not just that we will put only the aggregated data, but it could be the consolidated data. For example, we have, say, clients coming from different sources. From different files, you get different vendor data or client data. So you bring it to the raw, and then you bring it to the silver, and you cleanse. But then finally, all the clients, I want to understand who are all the clients in my company who are all the clients that is associated with my company. So in that case, you can consolidate the data and make it like one single source of truth for the clients, and then you can bring it to the gold layer. Or in typical analytics in the OLAP world, where we aggregate the data, right? There will be a lot of transactions. You wanted to have a summary of data, or you want to have aggregated slice and dice analysis of data. So then you can get the data into the gold layer. In silver layer, it will be more granular data. And in the silver, you can have more aggregated data, or you could have the combined data of from various sources. And quality wise, as data is not that granular as in comparison to silver, it could people could easily slice and dice using the aggregated data, and it can be very easily used by different reporting tools for the aggregated summary. Exceptions would be that it may not, because for images, video, audio, there's not, it may not be a right place for that. And like data scientists and ML engineers may not go to the gold layer. They may go to the silver layer, because the more granular data will be in that area, right? So from different sources, they may want to do it in a different way to prepare the model. So they may go to the silver rather than the gold. It's not that they may not come to the gold, but likelihood of them going to the silver is more. And again, who builds it is data engineer, and who uses is primarily it will be the management or any decision maker, business users, because they see the aggregated data, and finance team or any other operational team or data modelers. So these are the people who will consume the data. And tool says like the data, the data could be held in warehouse, it could be in the lakehouse, or they could provide a SQL endpoint from where people will consume it to create different reports. And at this layer, it provides very high insights uh, uh, and for about the data, and uh, uh, it's easy to get the numbers because I mean, people at management, they look at the numbers at a very high level, and then they drill down more into the granular level, right? So it is a data where people can easily summarize, and it is easily consumable and understandable by the end user. The pain points would probably be like the people may do over aggregation of data, which is may not be required. Sometimes we may try to do over analysis, and which could lead to overdoing of things. And like for example, in OLAP and all, we take the process data, right? Since the data volume is high, you would have aggregated and kept it, and it uh, may not be sometimes the real data. You might have to reprocess the data to keep it updated. And there could be some business logic conflicts where, like, when you are from multiple sources, if you are consolidating data into one single table, like client, for example, then there could be some business logic conflicts which may need more discussion and going back to the business and all the things. And the data quality issue could be there as a result of complex business logic, which will, and because the data will evolve as and when it evolves, the data will be better. And at the end of it, maybe there could be lack of governance. So people need to keep an eye on the performance, data quality, and the governance part of the data. So that's about the layers, different layers that is there in the medallion architecture: the bronze, the silver, and the gold. So once the data is then there in the gold, the data is available for the semantic model, and then which is consumed by the various reporting tools. So when we design the data migration or the data ingestion, as usual, we need to focus more on the volume growth of data and the processing needs. And it is this architecture is very, I mean, it's coming into prominence more in the cloud native solutions where lakehouse is used, and that it is easily elastic and the scalability is easy to do. And regular monitor and audit of data quality across all layers has to be considered, and as usual, indexing, partitioning, and caching techniques need to be applied so that data is processed in an optimized way, and also the storage is optimized. And people always need to have an eye on the cost that is associated with storage, processing, and the transfer. Yeah. So a brief note on a Microsoft Fabric. It's a the new tool, tool that Microsoft has released, and it is a, like a uniform, unified analytics platform. Now, basically, earlier what is we used to have the Azure Data Factory or in or other services in Azure portal, and then the Power BI was kept in a separate capacity. So now they have unified like all the data engineering to one so that we can have a seamless connectivity across various tools. So various tools available within the data fabric is like data pipeline, which is equivalent to the ADF that we have in the earlier version. And then we can also process the data using the data flow Gen 2. And the Databricks, earlier we used to have Databricks in the Azure, and now it is called Notebook, where you can write Python code, Spark, SQL, and all. And we have warehouse, and then we can create a semantic model, and we have a concept of workspace of, and within this workspace you can create a different services, and you can create like scorecard, lakehouse, and so Fabric Lakehouse is very is a very like a core feature of Microsoft Fabric. and it provides a modern and unified data architecture that bridges the gap between data lakes and data warehouse. Like it allows us to store both unstructured and structured data, and they promote to have a one lake kind of environment where it is a single source of truth. Like mostly what happens is in the enterprise, a lot of different teams start getting the same data and create duplicate data. So with the one lake house, one lake, it's you can have a one single source of truth, meaning we can all get the data into a single place and then have it consumable by all the different the teams. So under the hood of the lakehouse, the Delta Lake is the core format which further uses the Parquet file, and this gives its own additional features like versioning and then the scalability and the power because it runs in separate nodes, and you can uh, uh, like up the cluster configurations and make it run faster in a parallel way. So that's about the Microsoft Fabric. And some of the common questions that people would have in mind when people have gone through the Medallion architecture is, okay, what's the difference between, like I have heard this earlier, is it really a different framework? No, it is not exactly a new framework. It is been built on top of the existing raw stage and warehousing kind of concept, but to suit the new modern data needs. Uh, and it is recommended that we follow that framework in the sense we have the bronze layer, we have the silver layer and the gold layer, and not like just have the silver and the gold, or directly have the bronze and the gold. So that, I mean, this way the traceability of data is maintained at each layer, and each layer is for some purpose. And schema handling in at the bronze layer is much more simpler when using the lake house because it allows you to have those schema changes on the fly. And data quality has be kind of each layer there is improvement of data quality, and there is a progression of improvement of the quality of data in each layer. So how does it benefit the data process is that most of the time like what we have seen is when we get any project on data migration, we generally don't know where to start with. So having a framework in mind helps us to have a streamlined process as to now we know that, okay, get it to the bronze, then silver, put the transformation in the silver, and then bring the data to the gold. And while following this process, you would have kind of covered the best practices that is generally required for data ingestion. So that would be the primary benefit of following the framework, and it is the same in any other tools as well, right? In ASP.NET or C#. I mean, you would always follow some framework, and that is the standard practice that you would do. And the one other main question is, okay, fine. So now the source may have say 250 columns, and then the source may have huge data. So in the bronze, you mentioned that data is as is. So do we need to load all the data and all the columns? Ideally, yes. But depending on the story or the project that you're working, if all those columns are not required and only if a subset of column is required, then you can just get those columns. And also the data wise, if there's a huge data and your project only addresses to that subset of data, you can always just bring the subset of data. But within that subset of data, it is advised to do incremental load. So these are some of the common questions that one can have when we read about Medallion architecture. Yeah, that's it from my side, and thank you for your time. And now we can move on to the Q&A session. There is questions.
Thank you so much, Vinithan, for such an insightful session. I'm sure everyone gained a comprehensive understanding of a medallion architecture. Now it's time for the Q&A segment. Feel free to drop your questions in the chat and we'll address as many as possible. Let's get started. Uh, Feel free to drop your questions in the chat, please. Vinithan, we have one question from Pawan Kumar.
Yeah.
The question is, what kind of validation can be part of each layers?
Yeah. So in say for example in the bronze layer, right? Generally between different when you are pulling the data from different system to the lake house, in terms of data types, you can have certain issues, right? So there are certain instances where you might want to keep the data type in the bronze as string only, right? So in that case, yeah, you can keep it as string and then you can get the data as it is. Or like some transformation like even is in Excel file, you can keep duplicate names. So the renaming of the columns, those things. But it's like more very minimal transformation in bronze. Only these kind of transformation where it will not allow you to process the data is the transformation, because the bronze is highly focused on keep the data as is, because anytime if there is any failure in the gold and the silver, you would want to go back to the bronze, view the data and then understand what exactly is happening. You don't want to go to the original source like the file or some source which is outside your system. So it will be easy for, and then also for the QA, right? If you see the advantages of QA can, for QA it will be more modularized approach. Like you have a source, you get it to the bronze, you completely validate between source and bronze if everything is looking good. So at this point you can certify that okay, at least from the source to the bronze, the data into your system is all good at the bronze, right? So then you can complete that and then you can move to the silver. And in the silver you don't need to bother about okay what data it came from the source. Say for example some other vendor is having some data in some Salesforce or some Snowflake or anything. You don't have to go there. You have certified that the data is good in the bronze, and now you focus on only the transformation that is applied on the silver. So now you only focus on the silver, then you certify the silver and then you can go to the gold and then only test the gold. So at each layer you can certify and then move on to the next, and then it will be like a modelized approach. So that is the advantage for QA. So in terms of validation to your question, it is very minimal in the bronze. Most of the validation happens in the silver, like deduplication is one of the items, or any business logic, applying of any business logic, linking the data, or sometimes the data that is there in the source, maybe like it may say for example in the source I may say it as active, but in my system I may say it as like what is this, like different word for active, like you may say it as it is a valid user. So this changing from active to valid user kind of transformation, right? This like the definition of master data between the source and your consuming system or app could be different, right? So in that case those kind of transformation can be done in the silver. And then like trimming of spaces, then checking for nulls and blank checks, blank value check, all the validation failures. So all these validations you can done on the silver layer. Then all the based on all the validation failure, you can mark it as rejected or not ready to be processed, and then move it to the exception tables. And from exception table, you can generate a report back to the business, and they can fix the data, and then you can rerun uh, to the bronze and then bring it back to the silver and revalidate. So it is going through it will go through a cycle of validation until you get a proper curated data. So these are different validations you can apply. When it comes to the gold, you can apply transformation to aggregate the data, or to like in different, all to build the hierarchy, all these kind of transformation can come to the gold.
Uh, Hi,
Thank
Pavan.
you.
I hope
Yeah.
you got the
Yeah. Yeah.
answer for the question.
Yeah. Thanks a
Uh,
lot.
well, then we have one more question from Kamal. The question is, how can medallion architecture be adapted for a multi-cloud or hybrid cloud environment while ensuring data consistency and minimal latency?
Yeah, so for the multiple sources, right? So basically, uh, at the bronze, if you have like data coming from multiple sources, say for example, you have client data, right? One is coming from some database, another is coming from Salesforce, and one more data is coming from Excel. So you get the data as is to the bronze into a separate lakehouse tables or data tables, and then keep as it is. Then back to the silver, again you get the data in the, in a structure that you want, but keep it separate tables and bring it to the silver, and then you can validate each data from each source separately. And then once this data is there in the silver cleanse and everything, the combined data can be brought into a single table in the gold. So this way you can handle the data from different sources. It could be either from Snowflake, or it could be from Salesforce, or it could be from some files, or it could be from some blog, it could be from SharePoint. So a different source of data can be handled in this way. Does that answer your question, Kamal?
Um, Hi,
Yeah. Yes, Vinithan.
uh, Vinithan, we have one more question from Arjun Sivan. His question is, are there any upcoming innovations that could enhance this architecture further?
Yeah, innovations would be, I mean, in terms of concept, the bronze, silver, and medallion is is a data like a data pattern that has to be followed in enabling the faster loading of data in each layer. There could be different tools, like for example, uh, if you have to follow the same thing in the older versions, you would have Databricks. It's a tool from a different company but integrated into the Microsoft Azure portal. Then you have ADF pipeline, which is native of Azure, and then you have Power BI, which is outside the capacity, like the Azure subscription. It's outside that. So these are the different tools at different places. So seamless connectivity to this each of the different tools, or it was very little bit tough. Now with the Fabric and unified platform, they have bought all the tools under one umbrella, and they are providing all the connectors to the different tools. So connecting from Power BI to Lakehouse, or putting the data from Python code to Lakehouse, or from ADF pipeline to Lakehouse, or from data gen flow to Lakehouse is very easy now. And so that's where it's more. I feel the innovation can come more on the tool sets that we're using, and how easily the developers can use the tool for seamless collaboration. So uh, because still there are certain areas within Fabric, uh, there are certain connectors which are still not available. So as and when it becomes more matured, you will see more connectivity, like connecting also from Fabric to on-premise SQL Server without using ODBC. So all those things. So right now there are certain limitations out there. We have to go to the route of putting the data from data pipeline to the lakehouse, and then process the data. So hopping into some other tools and using the tools within the Fabric workspace, I think that's where a lot of innovations, I would say improvement can happen. And
Does it answer?
maybe some there could, in terms of framework, maybe there could be some improvements, or change in style for real time. From for different, we talked about that there are certain pain points in other kind of data, right? So mostly we are talking about Excel files, database, and all those things, right? But what about video, audio, and other different data sources? So there could be some because as since there are now a lot of emphasis on AI, people are talking about AI. The source data source, lot of data source will come into picture for analytics. So seamless integration of other media like video, audio, and other stuff, right? So there could be some real nice, cool stuff to be integrated into the fabric, basically. Framework wise, not that much, but into the tool set, that could be. That's where I think people will look at.
I hope that answers your question, Arjun. Hmm?
Yeah, thank you.
Yeah. Thank you, Nitin, for answering Arjun's question. Any more questions, please put that in the chat box. I guess there's no more questions,
Okay.
Vinithan.
Yeah.
As we wrap up, I'd like to thank Vinithan for such an engaging and informative session. A big thank you to all of you for being such an attentive and interactive audience. It's been a pleasure hosting this webinar. Stay connected with Kalpita Technologies by following us on LinkedIn for updates on upcoming webinars and the latest industry insights. And once again, thank you for joining us today. Have a great day ahead, and we look forward for seeing you at our next event. Thank you all.
Yeah. Thanks for your time.